Welcome everybody. We're going to get started here. This is latest and greatest topics in ArcGIS Runtime SDK for Qt. My name is Lucas Stanzinger. I'm the product owner of the Runtime SDK for Qt team. And this is Neil McDonald. He's an engineer on our team. He's coming all the way over from Scotland. So today we're going to talk about the Runtime SDK for Qt and some new features that we have in our SDK and also in the Qt framework. So first we're going to talk about what's new in the Runtime SDK. Then we're going to go into QML and talk about some new JavaScript language features that are supported with Qt 5.12. And then after that, Neil's going to dive into some new Qt 5.12 table view and creating a QAbstract table model. So we're hoping to have a little bit of a mixture of QML and C++ demonstrations here. So first thing for new features with the SDK, we're supporting a new platform starting at update 5. The platform is Android 64-bit, also known as Android ARM v8. This is important because it's required for Google Play submissions starting in August of this year. This will be available with our update 5 release, and also if you're using the runtime through App Studio, it will be available through App Studio with the next release. The only other thing to mention about that is Qt 5.12 switched the underlying compiler for Android, so you'll actually be using Clang instead of GCC, so there's some compatibility differences. You won't be able to use our new version with an old version of Qt because there's a different compiler. The next thing we want to talk about very quickly is a new platform, Linux Embedded Beta. So you saw it in the plenary this morning. Carrie showed our dynamic situational awareness example app, and that's running on an embedded device. It's a Jetson TX2 NVIDIA device. So this is currently publicly available. If you go to our early adopter site, you can sign in and get access to the binaries and start building apps with ARM 64-bit devices. We don't know what people are going to build yet. There's many possibilities: IoT, onboard vehicles, or helicopters or drones. Qt, this is really Qt's bread and butter. They really thrive in the embedded space. So we're going to test it out and see if anybody's interested. We've got a lot of sample improvements that actually Neil's been working on over the last couple of months. One of them is a search in the viewer. We have almost 150 samples now that help people build their apps and understand how to use the API. So Neil implemented it with a QSort filter proxy model, which basically means it's very fast to filter and sort to get the most relevant features to the top. So here in the screenshot, you can see raster. We can find all the raster samples easily without having to search manually. We've also upgraded all of our samples to use Qt Quick Controls 2, which gives us a nice consistent styling. And it also allowed us to get rid of our scale factor code. So something we had to do in the past was multiply any pixel values by a scale factor to make sure things on a high-res Android device versus an old desktop monitor look the same. Now Qt handles that for you just with this QGUI application call on the bottom bullet here. So it's much more simple. It looks a lot cleaner. All right, so now we're going to dive into QML and JavaScript features. So previously, the JavaScript engine that QML is based on was running ECMAScript 5, which came out in 2009. It works pretty well, but it's kind of limited. And if you look at the code that you have to write, it looks a little bit out of date. Qt 5.12 brings in support for ECMAScript 6 and 7. No 8 or 9, but 6 is really the big one. It brings in a lot of the new JavaScript language features. So the following features are now fully supported and work with our API. We've got arrow functions, constant variables, block scoped variables, string interpolation, function default parameters, and classes. So let's dive into a demo here and look at some code. So how many people here are JavaScript QML developers? A couple, okay. Are the rest of you C++ developers or just kind of generally interested in Qt? Second one? Yeah. Sorry, it's kind of hard when I ask two questions right in a row. Okay, arrow functions are pretty popular in the JavaScript community. They allow you to define anonymous functions, but it saves you don't have to write the function keyword and you don't have to write the return keyword. And it also allows you to share the same this as what the scope of the function is. So it's very useful if you have a lot of callbacks. So an example here, if we wanted to loop through a list of layers and print out the layer name, this is the old code right here on line 72. Map.operationallayers.forEach, and then you pass a callback function that will be executed on each element in that list model. So you have to do that by using the keyword function and passing in the parameter. With ECMAScript 6 and Qt 5.12, you can now just do the parameter and then this, what they call a fat arrow, and then your body right here. So in this case, I don't even have the curly brackets. If you wanted to have multiple lines, you could add the curly braces in as well. So it just makes it a little bit cleaner, especially if you just need to do one-off anonymous functions like that. So you can see here, it executes exactly the same output, prints the 3 layer names. So not a lot of functionality difference, but it's something that will modernize your code a little bit. The next bit is constant variables. So if anybody uses JavaScript, they're familiar with var. Var's been around forever. It's basically a mutable, it can be any type at all, but it's mutable. But sometimes you might want to have some type safety and make sure that you're not going to be able to modify that later. So you can use the new keyword const instead of var. It's exactly the same, except it's immutable. So here I've got some code that creates a point and a viewpoint, and then I'm setting a viewpoint on a map. And instead of using var, I'm using const just to guarantee that that doesn't ever change. And you can see it sets to my viewpoint. So again, nothing too exciting. It doesn't functionally do anything different, but it gives you some safety in your code. So I'd recommend always starting with const, and then if you know you need to modify it later, switch to var. Or we've got a third one now called let, and this gives you block scoped variables. So here you say let x equals -90 and let y equals 45. But then inside of this block, I'm creating another new set of variables and setting values here. On line 119, what will this print? With the let keyword, this will actually print -90, 45, because this is only valid within that block. If these were vars, that would clobber it and it would be 0, 0. So it's just another trick, I guess, if you want to potentially have name variables that might end up being the same name in different blocks. That's where you can use let. The next bit is the default parameters and functions. So this is pretty ubiquitous with a lot of programming languages. Here I've got a function called createPoint that takes an x and a y. And then it also takes a well-known ID of a spatial reference. And what I've done here is I use the equal operator and given it a default value. So when I call this function, I can just pass in two parameters, and then it will go to the default if I don't provide a third. Or I can provide all 3 if I want to override it. So this would be useful because a lot of people don't know what well-known ID they need to pass in. They don't know even what their data is in. A lot of times it's 4326, so we can make that assumption and hope it works. So you can see here in line 142, we're only passing in 2 parameters, so that will use 4326. And then line 145, we're passing in 3, so it's going to use 3857, which is Web Mercator. So you can see the difference in the JSON here reflected. The next bit is string interpolation. So this is useful when you have a bunch of different strings that you want to put together and then display somewhere. So usually what you'd have to do is take the string and then use the plus operator, and then in JavaScript it can combine two different strings together with the plus operator. And it's not too bad, but it ends up being a little bit clunky looking. You have to remember to add your spaces before and after, and if I delete this, then then I've got a syntax error because we have two pluses there. With ES6, you can use the backtick right here, and when you want to reference a variable's value, you just do a $, and then inside of an open and close curly brace, then you put the variable in there. So it just cleans it up a little bit. If I end up needing to get rid of that, it's still a valid string. And last but not least, we'll talk about classes a little bit. So we saw in the plenary this morning, there's some talk about Geojson points, Geojson layers. Let's say I want to create a class for Geojson points in JavaScript code inside of Qt. I just use the class keyword and give it a name. And then here I'm defining the constructor. It takes an X and a Y, and it takes a properties JSON object. So that's one of the key differences between just a standard ArcGIS point and a Geojson point. ArcGIS is just the X and Y. Geojson is X and Y, plus it has its attributes stored right in there, all in one. Also here I'm setting a default in case the user doesn't want to provide any attributes. And then inside of the constructor, I'm setting up all of the initial properties, and I'm returning a JSON object here that represents the JSON of a Geojson point. So to create an instance of this, I would say const Geojson point equals new Geojson point, and then pass in the parameters to my constructor. And then I can stringify the JSON here, and you can see I've got a valid Geojson object now. So taking that one step further, you might want to incorporate some inheritance. So I talked about how ArcGIS points and Geojson points have similarities. They both have X and Ys. So why not share that? So here I've got a class. This is my base class, ArcGIS point, with a constructor. And I've got a JSON property here as well. And then here I've got my Geojson point class using extends keyword here, and it's extending my base class ArcGIS point. And I'm defining a new constructor for this subclass called with an X and Y and the properties here. The key thing here is that I'm calling the base class constructor with the super keyword there. And I'm also overriding the JSON property. So here you can see I'm creating a new Geojson point with its inheritance and printing out the JSON. Whereas here I'm using the base class. So, yep. Here you can see the two different outputs. And the last thing I want to show are static functions. So this is something that's pretty common in most other languages. Basically the ability to call a function directly on the class itself instead of having to create an instance of it. This is really useful if you want to create like static factory methods that you don't have to create an instance. Like for example, ArcGIS point, if I wanted to create a class that represented that, but I want to be able to create one from a Geojson object, I could declare a static create from Geojson method that will take in Geojson object and return to you a new ArcGIS point. So that's what I'm doing here. It takes in a map. It gets the X and Y values. Ignore that I'm not being too safe here and checking to make sure that these indices are valid. And then I'm returning a new ArcGIS point. So to call that static function, notice here I've got a capital A and I don't have the new keyword. I'm calling it directly on the class. I'm not calling it on an instant. Yeah, so that's not all of the new features that are with it, but that's everything I'm going to show. Pretty much anything that you see with ECMAScript 5 and 6 and 7, it should be supported within Qt 5.12 now. One thing to note is the Qt creator that ships with 5.12, it'll show up as a syntax error because there's a little bit of delay in getting the code interpreter in the IDE. Everything will still work, or you can use the beta that's available right now. That's what I have installed, and everything is showing up properly. So yeah, if you use QML or App Studio, I encourage you to start trying to integrate ES6 and ES7 features. So with that, I'm going to turn it over to Neil, and he's going to talk about some C++.
Visualizing your data. So let's go on to the next slide here. So let's say that you run a query on a feature table, and you've received your result nominally as a feature query result object. What now? How do you effectively represent that query's data? And what if you want to run a variation on that same query, or run the query on a different set of data? You want to visualize that as well. These kinds of workflows are integral to end users because representing data on a map is just half the battle. One view I'd like to talk about quickly is Quick Control 2's table view. So this is a new table view for QML, and it's aggressively performant, as I like to call it, because it reuses delegates that you give it throughout the entire system. So as you're there flicking through the table, delegates are used and reused, so you have to be very careful with storing state in your delegates, to the point that the table view has kind of scary signals like on reused and on pooled to deal with that. So is it easy to represent a query in this kind of table? The answer is yes. At the end of the day, as long as you have your data represented in a Q abstract item model or a variant thereof, it will work in whatever view you want, be it a list view, tree view, table view, and you can even have your model consumed by more esoteric systems like Qt charts, where you could put it on a line graph or, say, a bar chart. The reality is, what I want you to take from this talk is if you are not putting your data into a model, then do consider putting it into a model now already if you're not. So I do have an example here. If I just load up, here we go. So here we have a Quick Controls 2 table view. So the bottom half is the table view, the top half is just a map representing the data shown from our query. So this is an incident report from Washington, DC. Reliably, I'm told, not a state. So, and in this text box here, it's a where clause. I can type in there, generate a new query, and just stick it straight into the table model. And the view will do all the hard bits for me, like repopulating the elements of the table, reordering things, adding columns or removing columns. So for example, if I said fid less than 5, I'd only get 5 items from my query. Represents fine. Likewise, I could say num people greater than 40 and type equals, here we go, people stranded. Well, hey, just works like that. And it's incredibly easy to represent raw query in model form. So here I have an example here. So here's the Quick Controls 2 table view, scary. And the only line that we actually have to use is data model attribute table. We just pass in our table, that's it. And what does that table actually look like? So if we go to our table model, it's only got 3 main functions which actually you need to use for a well-formed table. The number of rows, the number of columns, and last but not least, the data for the cell at a specific index. So if we go into what it actually looks like here, we say on our table, hey, set query. What does it do? Well, first we tell any downstream consumers that we're going to reset the entire table model. We're going to go ahead and say, if you're a view or another model consuming our model, that we're about to be invalidated. Any rows or columns that you're using, relook at them again because they're now invalidated. So by the time we get to end result model, table's cleared. Next, we tell it, here's the number of fields in our query, and these fields are going to represent our columns. So here's the number of columns are going to be in our table. Nice and easy. And then finally, we just let it know, hey, here we have a number of features in our query that we've returned back. Here's the number, these are going to be the number of rows in our table. Done and dusted. And all the functions after that, say row count, or column count in this case, so here we've got row count is number of features. Column count is number of fields. Data is nothing more than, hey, can you get me my feature and my field and the value for this field from the feature's values. All the code you see up here is just making sure that the values you pass in aren't invalid out-of-bounds errors. The most important lines are these three at the bottom. That's all you need. And last but not least, we have a header data. Just any well-formed table tends to have a header, and it's simply, hey, what is the alias of the field for this specific column? And that's all you really need. And that is, I think, a very powerful system. And if you're a QML developer here and you feel, well, this isn't necessarily relevant to me, QML table models are coming to Qt very soon now that we have table views in QML. And as I've got time, I think I can actually talk about Qt Abstract Item Model Tester. So, if you've not used this before, it may be worth exploring. It's existed since Qt 4.9, but not really in a supported format. Abstract Model Tester, you've always been a C++ file you had to come and download and then put into your application. But as of Qt 5.11, you can now bring it into your application using testlib, such that you can just use this tester to go into your model and look at any kind of errors that you have made during the application running, such that I use this on the model I showed right now, and I caught one. I had an off by one error in my begin insert row columns. But it does much more than that, like checks for referential transparency and checks that the children calls, such as has children or number of children, match up explicitly with, say, the rows of your item data. So if you're not using it and you do want to represent data in models, now's the time. Thank you. So 4.
So yeah, just to wrap up, we talked a little bit about the new features that we have in the SDK. Watch out for the embedded Linux. If you're interested with that, come over to the island and talk to us about that. We'd like to hear what you're trying to build. Do try the new samples and the new search that Neil's worked on. And again, we hope that if you're using App Studio or QML, that you can start using some of the ECMAScript 6 and 7 features, because that's really the direction that the language is going. Yeah, so with that, I think we have 2 minutes or so, and then we need to get out to let the next group in. If anybody has any questions at all. Yes?
I'm afraid I don't. So the question was, do we know when the model is coming to QML? So there was, I think it was Nathan Chris who did a blog post when TableView came out, and he just added as an afterthought to his blog post there, so I don't have much more information than that, unfortunately.
All right, thank you very much.
Thank you.